I'm Deep Jariwala. I'm an associate professor of electrical engineering as well as material science and engineering at the University of Pennsylvania. And I do research in a variety of different areas, but they're mostly centered around materials, novel materials, and their applications in electronics, optoelectronics, photonics, quantum sciences, and so on. My lab has pioneered various discoveries in these fields over the past several years. We focused mostly on low dimensional materials, so materials which are nanoscopic in one way or the other. I think this is a very important award. And the reason being that the award is judging not your pedigree or your prior accomplishments, but more so what have you done as an innovator recently in your independent career. And I think that is one of the highest forms of recognition or most meaningful forms of recognitions to an early career scientist like myself and many others, that what have you been known for or being recognized for that you have done in your independent career, not supported by your PhD advisor or postdoctoral advisor or other mentors in the past. So I think this particular award from Wiley and Advanced Science journals particularly focuses on that aspect, which is really rewarding and meaningful to early career scientists. Um, so I think that's the main aspect of it. Professionally, if I again look at it, the people who have won this award previously, other young scientists in the past year or so, and also ones who have won it this year, they're all highly accomplished. In fact, many of them I see at conferences all the time, and you look up to some of them. They have accomplished so much in such a young career, so it's really an honor, and does help promote my research group, my PhD students' research to the broader community, and brings them the much desired visibility. I think this is a very important question because this is the type of thinking that drives research careers or different directions in different research careers. The way I like to go about is a little bit more practical, right? Which you could say is true because I'm an engineer by training. So I like to identify an existing problem, right, in current technology, right, and then try to work backwards and see how I could solve that problem, right? It's a little bit different than how many basic scientists like physicists and chemists think that. What are the known unknowns and unknown unknowns in nature? And let's try to, find or identify or solve those known unknowns, make them known, so to speak, right? That's it's a little bit different. My approach is slightly more different than that, right? And what happens oftentimes when you try to attack the problem this way is you find that the potential for breakthroughs often lies if you are curious about two different fields of research. Okay, so if you are curious about one thing and then you don't know much about the other thing, but you try to learn and then bring them together, it is at the intersection of these different areas, different fields, different subfields, different lines of thinking is where the most breakthrough ideas are hidden, or I wouldn't say hidden, but they come from there, right? So I think that is what I have found, and curiosity at the intersection of disciplines, subdisciplines, and fields is what has been my approach and has been quite rewarding so far. None of the things my group does are in isolation. They are in strong and very heavy collaboration with a multitude of people. And this goes back to my training. So I was by training a material scientist, but my advisors and my thesis committee comprised of electrical engineers, chemists, and physicists, right? Then I did my postdoc in applied physics, and now I'm a professor of electrical engineering. So I've sort of sampled various disciplines. This is important because it brings perspective from different places, and it allows me to think broadly and collaborate with people across disciplines. So even though I sit in electrical engineering, I'm constantly talking to material scientists across the street, chemists and physicists who are also across the street, right? And trying to bring them together. Not just in terms of bringing a material to a particular device or bringing a measurement technique to a particular material, but even at the divide, I try to bridge the divide between experimentalists and theorists. Right? Oftentimes, you do experiments, you're very confident of the results, but you cannot explain it by any known theory or known theoretical phenomena. So you have to go to the theorists to help you identify where either your experiment is wrong or something that is missing in the theory that can help explain this experimental observation. And so I've benefited a great deal working with all these kinds of people, especially at UPenn and the independent research which we have done at UPenn, which has contributed to this award. I would say Professor Eric Stack, Professor Troy Olson, right? These people have immensely contributed. Professor Sherry Kagan in my own department, various other people in the physics department, chemistry department, like Professor Chris Murray, Professor Andrew Rapp, and others. So I'm very thankful to all of these people for broadly collaborating me. These are all physicists, chemists, material scientists, and that has brought our research to fruition. One thing I would say to younger scientists is it's a pretty daunting feeling when you first start your independent research career, right? Because so far, at least when you were doing your PhD, you're doing your postdoctoral research, you had a mentor, a professor, or a group leader under whose shadow you were working. And when you are independent, I can imagine it is very daunting. But I think one all the young innovators or young scientists use this as an opportunity. The biggest single line take I could take is that be fearless. When by fearless I mean doing things that you wouldn't conventionally do, right? Out of fear, right? Because if you keep doing the things that you have done before, because you are less fearful of those, because you know those things have worked, right? You are never going to be very innovative and make yourself stand out. Only when you do things that are very different or significantly different from what you have done in the past is where there are high chances of failure. But if those high chances of failure fear you, very unlikely you will even have a shot at a big success. But if you take those chances and many, many chances and are not afraid of failure, eventually you will strike at breakthroughs. You will strike at discoveries that are so different, so profound, and so innovative than even rest of your peers as well as your advisors that it will truly make you stand out as an innovator in by yourself and give you the recognition that you most deserve, right? So I think that is sort of the key the message I want to give is be fearless, which is at the core of it, to explore directions that are different from the past.